So this is the problem we are going to solve. So let us write down Laplace transformation of sine bt divided by t is how much? That is the question that we have. The answer is straight. You can write down the straight away answer from this particular problem. The answer is given by the integral. So straight away you can write down the answer is given by this integral. So you can write down like this integral s prime equal to s to infinity. You have f of s prime. So what is f of s prime? It is nothing but the Laplace transformation of sine bt. That's all. In which s goes to s prime. So s going to s prime is not a big issue. So you should not get confused because of that. Okay. You cannot have the lower variable s and then the quantity inside integration also same variable. No, that is to be avoided. Only for avoiding, you are just renaming the variable s to s prime. S to s prime is only renaming. Okay. So that's all about it. So and then finally you have the ds prime multiplied by ds prime. So you get the answer in one line here. So the factor 1 divided by t, what happened to that factor? That is the question. The 1 by t factor has been converted to this integral. That's all. So once you delete that 1 by t factor, what is left out is only Laplace transform of sine bt, and that's what we are writing that. This Laplace transformation, after taking, you just change the symbol here. That's it. So the answer is now trivial. The integration is also quite easy. So now you can see how to do this. Therefore we have integral s prime equal to s to infinity. What is Laplace transformation of sine bt? It is b divided by, of course, this kind of basic or elementary functions we have already done in the very beginning. Maybe lecture number 2, 3, etc. you verify. There we have done the Laplace transformation of sine bt. So b divided by s square plus b square. So that is the Laplace transformation, in which the variable s has to be replaced by s prime, and then this integration is with respect to s prime. And that's all. This integration is trivial integration. You'll be knowing b is a constant, so we'll take the b outside, and you already know this. So what is this? Tan inverse x, right? So in case if you are going to have a here, suppose if I am going to have a here, then you can have an x by a. Alright. So if there is a here, there is an a will come, and then you must be having 1 by a. Isn't it? So if there is a coming into picture, square is there, fine. So that is what you are going to use. So we can now write down that this b has come out. Then I will be writing 1 by b. This one I am writing. This one. And then I will be writing, this is tan inverse of x by a. So I will be writing s by b. So s prime by b. And that's all. So all the integration is completed. We are going to substitute s prime equal to s to infinity. And which is nothing but this is cancelling tan inverse infinity minus tan inverse of s by b. So this is your answer. So technically speaking, you got the answer. Tan inverse of infinity minus tan inverse of s by b is the answer. But however, you can just simplify 1 or 2 steps. So whenever it is possible, you can simplify, otherwise you can leave. Here you have to understand one thing, that we, as I already told you in the previous class also, you cannot substitute infinity into any function. No, technically this is not the way to substitute, but what we mean by putting that tan inverse of infinity is how the tan inverse function will behave for extremely large values of its argument. That is the meaning. This is argument, right? This is argument. So technically what it means to say is that you are actually asking the question, if this were the variable, or we say the argument, you are asking what happens in the limit of x approaching infinity. So that is the meaning of tan inverse of infinity. So actually that is the meaning of tan inverse of infinity, and you already know that pi by 2 is the answer. So this is pi by 2. So pi by 2 minus tan inverse of s by b. So the answer is pi by 2 minus tan inverse of s by b. which is nothing but you can leave it here. This itself is the answer. But if you know a little bit of trigonometry, okay, very elementary trigonometry, then you can actually write down that this is nothing but tan inverse of, you invert this, b by s. And this is the answer to this question. So this pi by 2 will disappear, and because of that this becomes inverted, and the reason is no basic relation is there. Sin inverse x plus cos inverse x is pi by 2. Tan inverse x plus cot inverse x is pi by 2. Because of these reasons, this pi by 2 is related with sin and cos, tan and cot. So there is a tan is there. Therefore what happens is this will be converted to cot. When you again convert cot to tan, this will be flipped. That is how it comes. So these are the two steps which I am not writing. But basically the reason is tan inverse of something plus cot inverse of the same argument is equal to pi by 2. So that pi by 2 is here. So because of that reason, this got flipped here, and this is the answer to this question. So ultimately these are all algebraic steps which are there. But the main step that I would like to again emphasize before closing this video is that the factor 1 by t has been forgotten. You simply forget the factor 1 by t, and instead of that you put an integral, and once you forget this 1 by t, left out function only you write down here. And that's all. The remaining thing is only your knowledge in basic integration and then the rest of the algebra. So the main single point, the only point that you have to remember for the Laplace transformation is this, that the 1 by t factor is converted to the integration. So that is the main part of this, and we will see with another example in the next class.